Hello everyone. We produce a lot of different kinds of tutorials and just like informational videos. But what happens is some of the discussions keep on coming again and again. And even though we have a lot of different tutorials and videos, people sort of ask the similar kind of question. So what I thought is like, why not make a little opinion video? So rather than a tutorial, it's an opinion video and it relies on other tutorials which we have already done. So if you need something very specific, you can go and look at one of our other tutorials and you will understand what we are trying to actually explain. So this one is basically looking at the politics of standalone versus non-standalone 5G. So we have non-standalone 5G today. We are going to get standalone 5G most probably either later on this year or starting from next year. I'm hoping to actually see a lot of announcements just around MWC about the standalone 5G. But also I want to actually tell you about what's going to happen with 4G speeds. Okay, so we are going to try and cover a lot of different things today. So a typical operator spectrum, if you just think about 2G, 3G, and 4G, the operator generally has multiple uh, chunks of spectrum or multiple bands of 2G spectrum, of for 3G spectrum, and of 4G spectrum. So what I've tried and showed is just a typical spectrum layout. So when we talk about say 2G for example, we are talking about 900 megahertz or 1800 megahertz, right? And 3G we are talking about 2100, most popular frequency. And generally an operator will have multiple of 5 megahertz chunks of spectrum. So what I've tried to show here is like three different chunks of 5 megahertz in 2100, right? But of course this is not according to scale. So don't think that like, oh, this is not 2100 or this can't be this particular frequency. This is just to give you an idea. And then in 4G we are looking at different bands, right? So we are looking at something like say 800 megahertz 4G, then we are looking at 1800, then also 2600 is another very popular 4G spectrum. So generally an operator will typically have different spectrum for different technology, right? And then of course you can have refarming, but I've covered refarming in another tutorial, so we're not going to talk about refarming just for 2G, 3G, and 4G specifically. For 5G, I keep on always talking about the need for three different layers of 5G spectrum, right? You have the coverage layer, which is sub 1 gigahertz. So, the 5G frequencies now start from 410 megahertz. And the coverage layer is generally typically up to around 1 gigahertz. But some operators might choose to actually have their 1800 megahertz spectrum as the coverage layer. There is no hard and fast rule what is a coverage layer. This is just terms which are being used in the industry to explain different concepts, or used by an operator to actually explain what they are trying to do. The capacity layer is what comes after the coverage layer. So right, if we assume the coverage layer goes up to 1 gigahertz, then capacity layer starts from 1 gigahertz and it goes all the way up till 7.125 gigahertz. Now why this particular frequency? Because earlier the 3GPP defined the maximum the highest spectrum in what they call as the FR1 or the frequency range 1 as 6 gigahertz. But in the recent specs, they have changed it to 7.125 gigahertz. So what we are saying is the capacity layer is what comes after the coverage layer and goes all the way till the maximum of FR1, which is 7.125 gigahertz. And then you finally have the high throughput layers, which start from 24.25 gigahertz to 52.6 gigahertz, right? And this is according to the 3GPP FR2 or frequency range 2. Uh, so these bands are generally referred to as the millimeter wave bands, right? But again, I have said this many times, millimeter wave in theory starts from 30 gigahertz, but we will refer to all this high throughput layer as the millimeter wave band, right? So an operator typically needs to have these three different layers of spectrum if they want to do 5G like really well, and we will see what I mean by that. So now when an operator has a 5G spectrum in addition to 2G, 3G and 4G, this is how typically it will look like, right? So the most popular coverage layer frequency, the sub 1 gigahertz one, is 700 megahertz band, right? Then the most popular capacity layer band is the 3.5 gigahertz or the C band. Then you have millimeter wave bands. Of course, different operators have different chunks of millimeter wave bands. Some operators don't have millimeter wave bands. So this is typically just showing how the 2G, 3G, 4G and 5G spectrum will look like. I have done a lot of different tutorials on spectrum, and the one which we did recently on just the 5G spectrum is a good one, right? If you want to understand just the 5G spectrum, you should actually watch this particular tutorial or video. So the 5G today is what we call as the non-standalone 5G. Again, if you want to know the details about different types of deployments, look at the 5G terminology presentation. So non-standalone is basically where you have 5G, the G node B, working in conjunction with a 4G network. So you have the EPC, you have the E node Bs, right? But you have the G node B just for the access part. So you have what we define as the dual connectivity, and I'll just show you an example, right? But this is all the 5G deployment today. So when you hear about deployment, 5G network deployment from anyone, from any network, right? In 2019, this is a non-standalone 5G. So whether it's Verizon or it's T-Mobile, right? In the US or in UK, it's Vodafone, 3, EE, O2, right? Or Swisscom or TIM, anyone, right? If you hear about 5G deployment, it's a non-standalone 5G deployment, and this is something very important to remember. I'll tell you in couple of minutes why. And if suppose somebody wants to understand, right, this is how basically the non-standalone actually look like. You have the terms en-gNB, right, which is basically a gNB that supports the legacy EUTRON interface. So we're not going to go into details, but I just wanted to leave it here for the sake of completion. So what we have today is we have dual connectivity. So you have your 4G, and in 4G we do carrier aggregation. That means we aggregate or we add, you can say in very simple English, even though add is not correct, right? But let's say add the different chunks of spectrum together. Okay, so whatever output you get or whatever throughput you get is basically the combination of throughput from each of these individual frequency layers. So here I've shown this F1 to F4, right? So when you have the 5G spectrum, right? So here I've shown it as F5 and F6, right? You can have carrier aggregation in 5G as well. Okay, I don't know if any operator is using 5G carrier aggregation today. I don't think they are, but you will soon start seeing 5G carrier aggregation, right? So in 5G you can have up to 16 different carriers or component carriers, CCs, and the maximum a carrier can have is 400 megahertz. But of course this is only the millimeter wave can have 400 megahertz bandwidth, right? The FR1 or the frequency range 1 spectrum, the maximum you can go is 100 megahertz. So with dual connectivity, what you are doing is you are aggregating the throughput what you get in 4G with the throughput what you are getting in 5G, right? And this is again important to remember. So your whatever, when you do speed test on 5G today, right? Whatever app you use, but whatever speed test the results you are seeing is actually the result of speeds, a combination of speeds of 4G plus 5G speed, right? Because your packets actually go through both the 4G and 5G, and typically this is right now only done in downlink. So you will notice that the uplink or upload speeds are still not that great. So for upload you would either use a 4G carrier or you would use a 5G carrier. Generally you don't do dual connectivity, even though in standards you can actually do dual connectivity, but I think the implementation today is just dual connectivity in downlink. So this is just in terms of equation, right? What we are talking about. So the 5G non-standalone speeds equals 4G speeds plus 5G coverage capacity layer speeds plus the 5G millimeter wave speeds. And as I said, we might not have 5G carrier aggregation right now, but it's available in the standards, and it's just a matter of time before operators start putting 5G carrier aggregation. So this is a simple way to understand the 5G non-standalone speeds. So again, I mentioned this thing in one of my earlier tutorials, right? So different operators and different parts of the world, they have different spectrum approaches, right? So in UK, for example, the 5G spectrum that has been auctioned is only the capacity layer 5G. So all the operators, they have got the capacity layer 5G, which is in the C band, so that around 3.5 gigahertz spectrum. None of the operators have coverage layer 5G spectrum or a high throughput layer 5G spectrum. In USA, on the other hand, is an interesting mix. So T-Mobile has a lot of coverage layer 5G spectrum in 600 megahertz. Sprint has capacity layer spectrum in 2.5 gigahertz, whereas Verizon and AT&T has millimeter wave spectrum. So the high throughput layer spectrum, and this is where things sort of become a bit challenging for them, because when you have high throughput layer, right, or millimeter wave or higher frequencies, it can only go so far. So you need more base stations to actually provide a good coverage. So it becomes tricky. So if they want to provide coverage nationwide, it's sort of impossible to do with a high throughput layer, because you would just need too many base stations. Okay, with coverage layer it's perfect, but with coverage layer you can't get great speeds. you know with capacity layer it's a balance. So you have more base stations than what you would have with coverage layer, and you can get better speeds. So it's a balance. In Italy, on the other hand, the operators have all the three layers of spectrum. So they all of them have the coverage layer spectrum, the capacity layer spectrum, and also a millimeter wave. So the high throughput layer spectrum. So this is very interesting because in Italy, all the spectrum was auctioned in all the three bands. So now the operators have that spectrum. So all they need to do is just start deploying 5G in all the three different layers. So when you have when an operator not have let's say the millimeter wave, they only have the capacity layer spectrum today. So what happens for them is, when you have the non-standalone, life is still simpler. So you can get a certain speed with speed test on 4G, but with 5G, right, you would also have the 5G chunk of spectrum, which can actually give you additional speeds. And speed test is really a very bad example, but I think that's how most of the people are measuring 5G today, because all they are looking at is how fast is my 5G, right? But they don't really understand, right, that the 5G speeds you get today is mostly 4G speeds plus some speed which is you're getting of because of 5G spectrum. Okay, and this becomes a sort of challenge for an operator, because now when the operator starts deploying standalone 5G, what will they do? So we will come back to that particular aspect, but this is I'm just showing, like, what are the 5G NSA speeds today. And the same thing happens, especially for operators who probably do not have a capacity layer or a coverage layer spectrum, but they only have a millimeter wave spectrum. It becomes very tricky for them, right? Because you can show great speeds when you get 5G, but your 5G is not available everywhere. So I have seen some videos, right, and some tweets where people are showing a certain speed outdoors. This is on millimeter wave. Then they are going inside a building or something, and their speeds reduce. But then they are saying is like, who says you cannot get 5G speeds indoor with millimeter wave? But the problem is, indoors, when you go indoors, right, you may not have any millimeter wave coverage, but you're still getting good speeds because of your 4G. So this is something you actually need to understand, because a lot of speed tests today are misleading. And what happens is, because you have non-standalone today, it's fine. But as soon as we go standalone, a lot of these things will actually start creating problems. So what is standalone? Covered it in lots of different tutorials. Is basically just a pure 5G network. So you have a 5G core, and you have the 5G new radio or the G node Bs connected to the 5G core, and that's about it really. So if you take the spectrum approach, which an operator might have today, is you just have the coverage layer, and maybe the coverage or capacity layer, and maybe millimeter wave. But if suppose you do not have a coverage or capacity layer, right, this creates a bit of a challenge, right, because millimeter wave does not go indoors. And this is where, you know if you have a standalone, you don't have the 4G speeds to provide you a backup. So sometimes, in some cases, it might actually make more sense for an operator to stay on a non-standalone than rather to go on a standalone 5G. Okay, so different operators will have different strategies, and this is going to be interesting to see what do these operators who only have millimeter wave 5G today, how do they go on standalone, or do they stay on non-standalone. But you can also start trying to bring in more spectrum, uh, in 5G. So an operator decides, well, they want to do a standalone 5G because it is sort of a real 5G. It makes so much more sense, right? Because things like slicing, you can only do slicing when you have a proper standalone 5G with a 5G core. You can do it in a non-standalone, but it's tricky, it's difficult, and it's a proprietary solution generally. So what they might do, what some operators might do, is they might refarm some of their spectrum, 3G spectrum, for example, to 5G, or refarm 2G spectrum to 5G, right? But what it means is they might have very limited service available uh, in particular case. So in this case, in 3G, the operator will have very, very limited service available, right? Because they have refarmed most of the spectrum for 5G, right? And the same thing will happen. So a lot of 4G spectrum might actually be refarmed for 5G. And it makes a lot more sense to refarm 4G spectrum, because what happens in 3G, you will remember that generally you have 5 megahertz bandwidth. So some operators may only have one particular 5 megahertz spectrum in 3G, or two, right? Or some of them may have two or three, but they are not contiguous. So this is where it becomes a bit tricky. Whereas in 4G, you operators typically have 20 megahertz chunk of spectrum available easily, so they can refarm some of these 20 megahertz chunks, right? So this, what this means is, what you will start seeing is, in the next few years you will start seeing that the 4G speeds will start reducing, as operators start refarming the spectrum. The frequencies will start, sorry, the speeds will start decreasing in 4G. So in short, I'm assuming you get an idea of what I've been trying to actually explain. So, you know, non-standalone 5G, it can provide great speeds, right? So, you have your en-gNB and the fixed wireless access case, works great with non-standalone 5G. Standalone 5G, on the other hand, can provide a real 5G experience, right? So this means low latency and also the massive machine type connectivity kind of experience. But the standalone 5G would need a lot of spectrum to provide real 5G experience. And this is also mainly in the FR1 or sub 7.125 gigahertz spectrum. So the best option is for an operator to have a lots of new spectrum. So they buy the spectrum right from the regulator, from the government, and ideally they need spectrum in all the coverage, capacity, and high throughput layer. But some operators will have, it costs a lot of money to buy spectrum, so they may choose to refarm either 2G 3G spectrum, generally. So but what it would mean is, it might mean switching off some of the 2G 3G networks just because they want to refarm the spectrum for 5G. But then some operators may also choose to refarm 4G spectrum, and this will lead to decrease in 4G speeds. But this can work in favor of 5G, because the operators will say like, look, you want real speeds, good speeds, you get 5G connectivity or 5G SIM or 5G phones, right? But if you want to stay on 4G, that's fine. You won't get great speeds because there is just a limited amount of spectrum that is available. So, just a disclaimer that this is just an opinion. Every operator will have a different strategy and they will have a different approach. So, hopefully, this short video gave you an idea about, the different standalone versus non-standalone speeds, right, and the 5G deployment, and what's going to happen with 4G speeds. So maybe you won't notice this in a year or 2 years, right? But you will start noticing in, like, 3 years or 4 years, that the 4G speeds are going down significantly, and you would know exactly why this is happening. So thanks for listening, and as always, feedbacks, comments, and suggestions are welcome. Thank you.